That is a game changer right there. Dang it, Joel, why didn't you tell me about that before, man?
I was thinking about it, but we had already moved on. What are we talking about?
We're a little light on news topics for this week, but I do have some, like, I don't know, in the doc I have pre-topic shit shooting category here, and just got a bunch of fun things to talk about. So the first one that I wanted to ask, and I've actually wanted to ask you this for a couple weeks, how often do you, well, you're pretty active in chat, right? In some of the other hacker chats that we're in. Yep. Do you use that more than you use social media, do you think? And what kind of role does hacker chats kind of play in your social life online?
Yeah, 100%. I mean, like, hacker chats are probably, like, close to 90% of what I, like, what I would consider, like, my social circles. So, like, most, like, I would say 99% of my social circles are, like, online. Most of the people that I'm friends with and, like, closely acquainted with are not people who I know, like, who like live near me, like physically near to me. And then day to day, like the majority of people that I talk with are probably hackers and hacker chats.
I feel like I underuse that substantially because we're in like quite a few little, you know, hacker chats that we've got together with some of the other hackers in the bug bounty community. And like, I feel like I'm kind of a ghost there. Or at least I'll go in there and I'll read it from time to time, but I'm not like interacting quite as much. And I mean, I don't really do that much on social media either, but I feel like, you know, when I'm ready to just like mindlessly scroll, I go to social media and, you know, scroll through Twitter or something like that instead of like going to the hacker chats and reading, you know, all you guys kind of just talking. So I think maybe I need to switch that around a little bit because whenever I get in there, I see you and the guys getting into some pretty cool stuff, and I wanna get in on that.
Yeah, I mean, I like to just like converse in there. So I feel like social media is a lot more like posty. So like when I'm using social media, it's more for me to like broadcast like publicly that I'm doing something. And if I'm in like the hacker chats, it's more like I'm having private conversations with like people that I trust a lot more than just like random public.
I definitely do that for like when I've got a bug and I know someone has some expertise, I'll like DM them in like, you know, one of the Slack channels or like on Discord or something. But like, yeah, just chilling. I think that's an important part of the hacker community that like, I don't know, I used to be a lot more religious about reading, you know, all the different channels and stuff like that. But I've just kind of fallen out of it lately since I've been, you know, running a little short on time with the rental property and some other things. So that's something.
Yeah, man. I mean, it's really hard to keep up with all of it too. There's like a ton of messages all the time. So even I like sometimes I just like I'll see like a bunch of stuff going on. And I'm like, I don't have time to do it, and I'll just mute the channel for like an hour. Yeah.
I feel that. Solid. The other thing I had here was, okay, just want to do a clarification because we did an episode a while back, which, by the way, I'm going to call out our audience on this one. Let me just pull up the statistics real quick. You all said, when I put a post on Twitter about what you wanted to see, you said that you wanted to see exclusive techniques and tool releases. And our Rebind Multi-A tool release and browser SSRF like episode is like one of the worst performing episodes out there. So one, you guys suck. Two, I'm glad you didn't listen to it because I actually made a mistake in there that somebody messaged in to info@criticalthinkingpodcast.io and corrected me on. This guy Cyphron shot me a message and said, hey, by the way, the DNS rebinding attack that we talk about in that episode, which if you haven't heard it, that bad boy's episode number 9, so go check it out. But I was saying that it works for Windows only. Because of the way the DNS rebinding works, like if you're in Linux or in Mac OS, it defaults to the private IP address first instead of the public IP address. But this guy Cyphron messaged me and said, hey, just FYI, one, the tool you made is completely redundant because NCC Group Singularity does the same thing. And I was like, okay, you know what, fine. But, you know, maybe there are some features in there that I have that they don't have or vice versa or whatever. But two, we can actually, you can use this attack to hit localhost-ish on Linux and Mac OS by hitting 0.0.0.0.
Interesting.
Yeah, so that's pretty cool. I mean, it's not necessarily something that, is going to get you access to an internal piece there, but it's better than nothing. So definitely check that out. Set as the target for that rebind 0.0.0.0, and you might be able to hit some internal APIs or something like that if it's sitting behind a reverse proxy.
Super interesting. It's very interesting behavior that it would default to like from going 0 to 0 to 0 to 0 to localhost.
Exactly, and you'd think with Linux and Mac OS, by default checking to see if they have a private IP address in that DNS resolution, they would also think about 0.0.0.0, but I guess they're not thinking about the reverse proxy sort of situation.
Yeah, so. That's super interesting.
Okay, dude, the other thing I want to talk about, this guy, the Flipper.
Oh yeah, one of these?
Yeah, are you serious? You had it sitting right in your desk right in front of you too? Yeah, the Flipper. Have you set this thing up yet?
Yeah, man. I've got mine. I have a custom firmware on mine.
Okay, Joel. All right, fine. I just got mine a while back, and I haven't had the chance to play around with it yet, but I feel like this could be helpful for the live hacking event that we're doing starting soon. So I'm going to get
bringing mine.
Yeah, I'm going to get some firmware on this guy, and hopefully we'll be able to report back how exactly it's working, hitting some Bluetooth protocols, and yeah, it's pretty much only going to be Bluetooth, I think, for this event that we're going to go after.
Yeah, I mean, I would be surprised if it's doing other stuff, especially in like the ranges that the Flipper is going to do, like sub gigahertz and stuff. Yeah. But it's always possible. I mean, sometimes you'll see stuff using like 433 megahertz.
Yep. So that's definitely on the list. The other thing that I want to talk about while we were on the topic of Bluetooth was I've been playing around in prep for this live hacking event, and if for all of you watching on YouTube, over my right shoulder there, you can see this giant like just HackerOne towel thrown over a bunch of things, because sitting under there is the like absolute crap ton of devices they sent us for this live hacking event that Joel and I are participating in coming up towards the end of April. And I realized that I had them sitting there on that table right before we started recording.
That may or may not be a giant blurred out square in the video they see.
Yeah, exactly. Hopefully I don't like move my shoulder and like show something I'm not supposed to show. But yeah, I've been playing. So one of the devices that we're targeting sort of has a Bluetooth low energy interface. I've never done any non-HTTP related hack. Well, like once or twice I've done some non-HTTP related hacking, mobile aside. And I started playing around with the Bettercap Bluetooth low energy module, and that thing is fire. Real easy to use, really consistent, and I didn't even have to use a, I don't know if this is just the Bluetooth chip in my laptop, but I didn't even have to use like the Ubertooth one or anything like that, any external cards, just the Bluetooth chip built into my laptop was able to enumerate the various services that I was going after. So definitely check out Bettercap's Bluetooth low energy module.
Yeah, dude, you were showing me that yesterday, and I haven't done a ton of Bluetooth hacking either. I do mainly either end up on like the network side, or maybe I'll like rip a chip and go into like the source code and stuff. But I had been holding off on buying like an Ubertooth or anything like that for like a while, just because I wasn't really sure what I needed and all that kind of stuff. And then I saw that recently, a couple months ago, they announced that the Ubertooth one was being like retired, basically.
Yeah, just as I bought it, of course.
I had one on my wish list for like months and months and months, and I was like, should I buy this? Delete. Yeah, so I did some other digging, and there were a couple people talking on Reddit and stuff that were mentioning the kinds of stuff that they actually end up using. And they had said that they own the Ubertooth, but for the most part, they don't end up using it a ton. And the basic impression that I got is basically it's like a Bluetooth receiver. That's pretty much like it. I don't really know what it does that is extra than that. So a lot of people were recommending this this U100D by Sena.
Check that out.
So this is pretty neat. It was like $30 or something. It was really not bad, and it has this crazy range. Apparently it can go up to like, I want to say like 100 meters or 1,000 meters or something.
Dude,
it's like
crazy.
It's really crazy. And I was using that yesterday with Bettercap,
Yeah.
And it was working great. I can't use it on my Mac like through Docker or anything. For some reason,
yeah, I
Bettercap
was curious to see if you got that working.
Yeah, it doesn't work with the drivers. They have a note in it somewhere in the documentation that you can't use the BLE module with like Mac or Windows because it doesn't support like the drivers or something like that. I was able to get it to work on my Windows through VirtualBox. So if I run it
really?
within an Ubuntu VM and I do USB pass through with the adapter, it works.
Wait. So you
VirtualBox
VirtualBox on Windows on your Windows box you had. Okay, for a second I thought you had said that you were on your Mac and then you had a Windows virtual machine and then you had a Ubuntu virtual machine on that. No. I'm like, Joel, what the frick are you doing?
No, I do. I have I have a Mac laptop and a Windows PC. On the Windows PC, I was running Ubuntu within a VirtualBox VM.
Okay.
And I had the Sena Bluetooth adapter plugged in and passed through over USB. Nice. And then I actually had to compile Bettercap from source because the one from apt doesn't have like BLE, the BLE module or whatever for some reason.
What the heck, really?
Yeah, super weird.
Did I do that too? Maybe I did that a while back.
Did you run it from a Docker container?
No, I didn't. I actually started playing around with it a little bit before when I was attacking a different surface and I didn't get very far and I had to move on to something else. So I might have compiled it from source back when and just had it installed on my laptop. But
interesting.
Yeah, I have that. My laptop runs. I just dual boot Windows and Ubuntu, and that's always worked really well for me because, like, at the end of the day, I'm running Ubuntu 99% of the time, and then that other 1% of the time is when I'm not at home and want to game, which is like very very minimal time frame. So yeah, that's how I just plugged it straight into my laptop had just a built-in Bluetooth chip and just used that. So that worked great.
Yeah, I'd imagine that most of the built-in Bluetooth chips probably can work, but I think it mostly has to do with the drivers that are installed for like Mac and Windows specifically, like they mentioned, that cause those kinds of problems. So probably just if you have Linux, you can just give it a shot. Like if you have BlueZ and it picks up your Bluetooth chip or whatever, your Bluetooth adapter already, then you're probably good to go.
Solid. Like I said, we're a little weak on the news this week. There's only one little thing. I don't know if you had anything, but the only thing that I saw was this Burp VPS proxy. Did you see that?
I did not. I saw that you posted it in the doc, and that was the first that I'd heard of it.
Yeah, so it's pretty much like it's a Burp extension, and the guy that has it on GitHub is Demondiv. But somebody posted on Twitter too. I ought to go find that tweet and give him a shout out. But it looks like my favorite type of Burp plugin, where it's just like it does something complex, but all you have to do is just take an API key and plug it in, and then just boom, it's done. Right?
Yeah, it's probably like one API call.
Yeah, it's great because what it's doing is it supports a bunch of different providers. It supports AWS, DigitalOcean, Linode, and you just drop your API key in there, and it'll just spin up a VPS proxy for Burp and go out there, spin it up, connect your Burp to it, so you're not constantly getting banned when you're performing some testing. So I feel like this is going to be really helpful when you have one of those stupid targets that like bans you every 2 minutes and doesn't help you get that fixed, because that's ridiculous.
That's interesting. So it's just for proxying your Burp traffic?
Yeah, it looks like it. Yep. Uses a SOCKS 5 proxy.
Okay, very interesting. There's this reminds me of a similar tool called Fireprox.
But that's for all of the that gives you a URL to hit, right?
I don't know. So my understanding is that it basically just like uses the I think it uses Lambda or something to basically just rotate your IPs so that you're not hitting it from the same IP for all your different requests.
It's not Lambda. What is it?
It's not Lambda. You're right.
It's like IP gateway or something like that. API gateway. Yeah.
Yeah. There you go.
Yeah. We should definitely.
Yeah. So it uses API gateways to basically give you different IPs for all your requests, so that you don't get like a single IP band. I'm not sure how efficient it is or anything like that, but that also might be a good option. Instead of having have an entire VPS setup, you could basically just have one of these instances and just like hit it until you get IP banned, and then spin up another instance.
Yeah, this definitely works well if you've got something like a setup where one host is blocking you, specifically, and then you can just spin up a Fireprox URL for that specific host and then hit that instead. And every request will come from a different IP. But if you're trying to attack, a target that has a bunch of different APIs that need to interwork together and stuff like that, then Burp VPS proxy might be better, so that all of your traffic is going through, a VPS, and then you can kind of spin it up, spin it down as you get banned along the way.
Yeah, but we'll link to both of those tools down below.
Yeah. All right, that's all I had for the pre-topic shit.
wanna dive right into it?
Let's do it, man. Let's get right into it. So get some water in you, Joel, because we're going to be doing some talk in this episode. We are talking about dynamic mobile hacking, specifically with Frida. This was sort of a sequel to the other mobile episode that we've got, which was episode number 6. So if you haven't seen that, feel free to check that out. There might be some, if you haven't seen that, depending on your mobile knowledge, you might be a little bit lost. But all right, I'm going to set the scene and then we'll jump right in. So
cool. What
we talked about last time was a lot of the basics of mobile stuff. We talked about all the different components, intents, activities, just kind of getting our hands dirty in Android stuff. And so what we kind of want to, but that was largely focused on understanding how Android is programmed and how we can read the code, largely talking about static analysis. So in the field of mobile hacking, there's, two primary, and correct me if I'm missing anything here, Joel, but there's two primary approaches. There's a static analysis where you read through the code and you try to identify vulns that way, and then there's a dynamic analysis, which is you're using a tool like Frida, or you're actually getting in the app and making stuff happen, and figuring out how the app works that way. So the dynamic analysis piece is kind of what I want to focus on today. But these two should be used in conjunction, right, Joel?
Right. Yeah. So usually I end up using both whenever I'm doing hacking. Like, I'll probably start with some static analysis, but
yeah,
you really want to figure out what's going on within the app, and some of those things are way too complex to try and figure out just by reading source code, and it's just simpler and easier to call it directly or look at what it's doing with Frida.
Yeah, for sure. So for those of us that aren't familiar with this, so dynamic analysis, just give me a brief overview of what that looks like and how we are able even to do that.
Yeah, so essentially dynamic analysis is just looking at or maybe modifying or hooking parts of the app while it's running. So it's happening dynamically. It's not based on you're not reading through the source code. You might be to figure out where you're going to set your hooks, but outside of that, it's while the app is running.
Nice. So the app is running. So we've got the app on a phone or on an emulator, right? What's your go-to in these sort of situations?
99% of the time, emulator. The only times I end up using a physical device, so for example, with the thing that we're working on for this upcoming live hacking event, I will be using a phone for at least part of it because it uses Bluetooth to do the setup initialization process. Yeah. And right now, as far as I'm aware, there's no way to get a functioning Bluetooth within the emulator. The pass-through doesn't work like that. Yeah. So there's no real easy way to do it. Maybe you could do it on Linux. Maybe you would have a little bit better luck. I'm not sure. Maybe the one time.
You see that phone sitting right there?
Yeah.
So I've already got a Frida script for you. I'll toss it over to you whenever you start looking at stuff. But okay, cool. So we're using 99% of the time we're using an emulator. What kind of emulator do you normally go to? I've got two that I'm aware of. I've got GenyMotion, and then I've also got AVD, Android Virtual Device thing, the thing that comes bundled with Android Studio. Do you use either of those?
Yeah, so I use the one that's bundled with Android Studio. You don't have to get it through Android Studio. You can download it, just the Android SDK, and it's called Emulator.
Oh, really? Okay.
That's the name of the binary. And you can use it the same way. You can call it. You can create the AVDs. You can do all that stuff. It's just probably significantly easier to do it through Android Studio, mainly because Android Studio has the stuff for downloading and managing the SDK packages. Nice. So you can download the latest Android SDK. You can download the Google Play image for Android O or whatever, and then you can install that and create your emulator and configure it. And then later on, if you want to run it just using the emulator command, absolutely you can.
Yeah, that makes sense. I literally every time, it's so annoying if you try to do it through Android Studio because you have to open Android Studio and then you've got to click the little more options button and then you click, the Android virtual devices, whatever, and then it launches up this other thing. So you've got all these windows, and if you close any of those windows, then it just closes everything. And I'm like,
honestly, I think it used to be a lot easier back in the day. I think they started to overcomplicate it like recently. Now, if you run an emulator, it shows like an integrated like window within Android Studio. It's like it doesn't like pop out anymore. So if you run just like emulator at and then like at your like AVD or whatever, like that's the syntax. It'll just spawn up a new window, like a QEMU instance, and you'll be good to go.
Perfect. Yeah, I should do that because I hate having all these windows open at once, and if I close any of them, then it just bloats up my desktop. So okay, so you've got the emulator up. So let's say you went and downloaded Android Studio. You've got the AVD, open AVD, select Pixel 5, build that guy. Now we're rolling, and we're interacting with that virtual device via ADB. And then do you normally have one of those devices that has access to the Play Store and then just go download the APK, or do you normally like pull the APK from somewhere and then like push it to the device using ADB install?
Yeah, so it depends on what I'm doing and what the situation is. I'd say like, especially if I'm using a physical device, I'll probably just download the APK because lots of times it's feature gated. So you might not even be able to download an APK that uses BLE if your phone doesn't register as having BLE with the Google Play Store. So if you're using some of those like Play Store downloader tools, you might run into issues actually trying to get that APK if your device doesn't have like the compatible features. And I've just found that you have to do it with like a physical device if you want to get it, or you can find it online.
Yeah. I when I was downloading this app and getting installed for the LHG, I tried to install it on my main phone and then set it up on my main phone. And then there's like some weird incompatibility with my specific device that I have and this version of the app. And it's, if you like dig deep into the like release notices on their website, it's like, oh, by the way, if you have this and this, then you're just not going to be able to use Bluetooth. And I'm like, I like set up that whole thing. And so, that's a little bit of a pain, but I think I had another, device sitting in my closet or whatever. And
is it an old device?
Working. Yeah, it is. And actually, so I had to update it a little bit to get it to meet the right like APK level or something like that. And it was a whole so process.
Almost certainly the problem is that it has Bluetooth, but it doesn't have Bluetooth Low Energy. And so it has Bluetooth, but not BLE, and it can't talk with BLE stuff. I've had the same problem with older Android devices that I can't use for Bluetooth testing anymore because they need BLE specifically.
Oh, wow. Yeah. No, this was an old device. I've just got like a little, like, actually it's right here. It's like this little, it's supposed to be like a little, cable management thing. I just have like a little label on it that just says
I know exactly. Is that from GitHub?
Is it from GitHub? Let me see. We definitely got it at one of the live hacking events. I think it was. Yeah, I think it was from GitHub. Actually, I put it over I have the label over the place where I got it from, so I have no idea. But I think I have
the same one though.
It helps to have a bunch of old phones around when you're doing mobile testing though, because sometimes you'll have those sort of weird incompatibilities, right?
I just have a stack of phones in my drawer. It's crazy.
Let me see your phone drawer. Anyway, okay. So we've got the app running on an emulator. We've got, so then you said we're doing this alongside with static analysis. So we're opening up the app in so also let me ask, refresh my memory. What do you do with JAD? You unzip the APK and then you decompile all of the DEX files with JAD, and then you open that up in VS Code. Is that right?
No, not even. I use the APK tool to extract basically the decoded resources and the DEX files.
Yep. And so now you've got Smalley, right? Not DEX.
Right, and then I use JADX to only compile source and not the resources, and output that into the same folder. So like I feed them both the APK. So I feed APK tool to APK to like decompile everything.
Right.
But like not pull out Somali and all that kind of stuff. And then I use JADX with the same APK to have it decompile only the source code, because I think JADX also does like resource decoding or something, but I prefer APK tools over that. And then I'll also feed JADX the APK, and I'll have it output into a like the same folder in like a source folder. So
JADX, if you pass it an APK, then it will go ahead and
it does Dexterjar and everything. Yep.
Oh, okay. I was wanting to do it the Joel way when I did this last one. I was like, all right, you know what? I'm gonna get it together. I'm gonna be cool. I'm gonna use VS Code like Joel, and I'm gonna like have it parse the whole thing.
I'll send you the commands that I use. And like the specific arguments and stuff.
Yeah, but I just, I always literally, I just open it all up in JADX GUI, and the search functionality is kind of shit in that though. So it's like, not sure if that's the right move, but it gets the job done part of the time. Okay.
It's especially nice if you don't want to like have it all on your disk, right? Yeah. Like if you just want to open a jar file or something and you don't want to have a million Java files on your C drive or whatever, then you can just use JADX GUI.
Okay, so the setup now is we've got an emulator, we've got the APK loaded onto the emulator, we've got our source code in front of us and VS Code or JADX or whatever we're using. And then now we want to start doing some dynamic analysis. One of the most common use cases for dynamic analysis is SSL pinning bypass, right? So talk to me a little bit about how that works. And then you've got a script somewhere, which I will try to find while you're talking, that does universal bypasses, right?
Yeah, so basically cert pinning, like in a nutshell, is the device verifying the certificate that is coming back from the server. Okay, so if you think about how proxying works, especially for proxying TLS or HTTP traffic, your Burp proxy, your system has trusted that the CA, the Burp like certificate authority cert, which is going to issue new certificates to sign all your different requests. And because you've trusted it at a system level, it's fine, and you can proxy your traffic through Burp. But if you weren't, Chrome would probably be throwing, certificate errors.
Just by default, so you have to do certificate pinning settings.
Yeah, exactly. Now, by default,
certificate checking, I guess, just certificate validation, right? This isn't necessarily pinning; it's just normal certificate validation over HTTPS.
Yeah, this is at like a system level. This is like normally your system is going to check that the cert that's signing the traffic is what it should be, and it's a valid cert, and it's not self-signed and all that kind of stuff, right?
Right.
So if by default, if you were to like install the certificate on your Android phone, you would probably be able to get like some apps through there. You would run into the same issues you would run onto a PC if you were trying to proxy without or with a certificate. Like for the most part, it would work, but certain apps, a lot of apps, honestly, implement this thing called certificate pinning, which is where inside the app, inside the app, they say, these are the specific SHA-256 or whatever hash. This is the specific hash of the certificate that it should be coming back from the server. And if it doesn't have that hash, then reject the request. And it'll basically drop the connection and it'll fail. You'll see it in Burp. It'll say like, TLS verification failed or certificate verification failed or something like that. And so what you have to do is you have to bypass that verification. You either have to tell it that every certificate is okay, or you just have to remove that verification step entirely. There are a couple different like core like HTTP libraries that are very commonly used.
So before we go into that, I'm going to try to summarize it like I was 5 here, okay?
Sure.
So by default, HTTPS is the thing that keeps our communication with the server secure, right? And the way that works is by having a certificate presented by the server side that says, hey, I am whoever they're claiming to be, and that certificate is signed by a certificate authority. That's like the big guy that we all trust saying, hey, this guy really is this guy. And we can validate that cryptographically because this really smart 5-year-old we're talking to here. We can validate that.
Are you smarter than a 5th grader?
No. We can validate that cryptographically by using like, because our device has a set of CAs that we trust, and we can tell whether that signature was actually signed by the CA versus by Joe Schmo. And so that's how normal HTTPS works. Now, when we are installing a device, a certificate, or when we're trying to, see HTTPS traffic on an Android device, we have to install Burp or whatever intermediate proxy you're using, HTTPS certificate, their CA certificate on our device to say, hey, by the way, we also trust Burp. And Burp just says, hey, I'm whoever the heck I want to be, and just, gives you a valid certificate for every person, coming through. And that is how you can sort of decrypt that traffic as from a middleman perspective, right?
Right. And again, the main distinction between certificate validation and like the standard certificate validation and certificate pinning that's happening here is that certificate pinning says specifically only these certificates are allowed for the traffic that I'm trying to send. Like, I'm trying to talk to this API, I should only be getting this certificate back or from this CA back. And if you're using Burp, that's not going to be the case. So you have to change it at an app level, not at a system level. You have to do both, actually.
Yeah. So what I just explained there was normal certificate validation. Now, we install the Burp certificate on the Android phone. There's a million tutorials out there to do that. Now, the phone trusts Burp, right?
Yep.
And if the app that we're using relies on the phone to do this validation, then we're Gucci. Everything's fine. We can see the traffic. We can decrypt the SSL. It's perfect. But
and you can test that, just like go to example.com, like HTTPS example.com, and see if your phone throws a cert error.
Okay. So we've got that, but then these tricky developers are going to try to trip us up here by adding an extra layer on top of that and saying, okay, not only are we going to validate the certificates, trusted at the system level or whatever, we're also going to say that if the certificate presented is different than this specific certificate, they put, the hash for that in the code, then freak out and don't send any messages, alert, attackers hacking us. Right?
Right.
Okay.
Right.
Solid. So that's SSL certificate pinning. It's a pain in the butt, man. It really is. It's a pain in the butt. So yeah, I'm glad we can figure out how to get past that. Yeah.
So you mentioned the script. I talked about this. I did a long interview with Ben, the HomSec, and we talked about mobile hacking and stuff. And we also did a large blog post for HackerOne about Android hacking. And in that blog post, I linked to this Frida script I think at the end. And this is basically my go-to script as well. That's the same script that I use for 99% of apps. I almost never have an issue with it unless it's a custom implementation of cert pinning somewhere. So basically, it just looks for a lot of the really common certificate pinning libraries that exist out there. Okay, HTTP, the built-in Android
TrustKit, Trust Manager.
Yeah, TrustKit. Yeah, exactly. And it hooks all of them at as basically a low a level as possible, so that generically speaking, it can hook most cases and it can stop cert pinning in most cases, including at a system level for if you're using the trusted certs XML or whatever, the new way that they do it with Android.
I'm reading through the script and what one of the things here is Trusty Trust Manager. Is that you naming stuff, or is that?
Yeah, it's a Trusty Trust Manager.
Trusty Trust Manager.
It's very trusty.
Oh my gosh, lovely. Okay. I don't know why that hits me so different right now. Trusty Trust Manager. All right, solid. So we'll link that. We'll link that in the description. Definitely check out Joel's script. And okay, so hopefully, if they're using one of these default, SSL pinning libraries, then you can just run this free. Okay, so we can just run this Frida script. We're gonna explain how to do that in a second, or talk a little bit about that. But run this Frida script, and then SSL pinning should disappear, and boom, you should be able to proxy the traffic, right?
Pretty much.
Yeah, that's what I've been doing with your script for the past couple of years, and it's been great. And I can confirm that it does work. I'll say 90% of the time, because there are some weird fringe ones out there, which I'll talk about if we get to the reports section later in this conversation. I'm not sure if we will with how long we're going right now, but yeah. Okay. So now, we set it all up. Burp certificates installed. you know, we're seeing some traffic go through, you know, in like our normal Android browser or whatever. You know, if we open up the browser, we go to Google and it doesn't throw a certificate error. But when we open up the app, it says error connecting to the server, you know, is what it says. Okay. Yeah. So that's a good indicator that there's some cert pinning there. What's the next step?
So if I'm trying to figure out like custom cert pinning, for example, one of the first places that I'll look.
Okay. So let's before we know whether it's custom cert pinning or not. I mean, do you just go right down the rabbit hole and try to find custom cert pinning, or do you run the Frida script in general, you know, right off the bat, and then if it doesn't work, then you try to go find it?
Yeah, I mean, usually I'll just try it out of the box. If it doesn't work, then I'll run my Frida script. If it still doesn't work, then I assume it's custom pinning.
Okay, so walk me through running the Frida script. Do we just like, how does that work?
Yeah, so Frida involves basically two main parts. There's Frida server and Frida CLI. So Frida CLI runs on, I'll call it the host. That's like your laptop or your PC or whatever, right? Where you're like running your scripts from and all that kind of stuff. And then the server runs on the device or on your emulator. So you download Frida server from GitHub from their releases. They have regular releases. You want to download the one that's specifically, it should be like Frida-server-version-Android.
Okay, this is the thing I always get wrong. So when I'm downloading that, hold on, let me pull up the Frida. So I'm going to GitHub, going to Frida, going to releases, right? And then they got this like list of all of these.
Yeah, and make sure you expand it.
Yeah.
Click show more.
Frida. So if I search for server, there's okay, and then there's specifically, so it says Frida server and then the version, and then we've got Android.
You want to be risky
x86.
and share your screen?
Oh yeah, hold on, let me see if I can
do that. We have this fancy software.
No way, this is nuts. Frida. Let me see if I can find the right tab here. There we go. This guy right here, right? Look at that. We are in the next.
Wow.
We are in the next.
That is so hard to read.
I don't know what I'm trying to say there. This is the future.
This is the future.
Let me just zoom in. So yeah, so we've got this, right? Frida server. Now we've got Frida server for Android, ARM64, x86, x86-64, all of these. How the heck do we know which one to download and which one to put on our device? And it has to be compatible with our actual Frida that's installed on our computer too, right? So how do we determine that?
Yeah, so I always just install the latest version of both, and that will remove any of that version confusion, whether or not it's compatible and all that kind of stuff. Just install the latest version of both if you're ever unsure. For the architecture, it's the same as like with Linux. So you'd run uname-a on the device over ADB, and it'll tell you what the architecture of the device is. If it's like Arch, or if it's x86, or if it's x86-64 or whatever. Most of the time, you're going to see either ARM, maybe titled ARM v7, ARM v7L, ARM EABI, or you'll see x86, or you'll see ARM64.
Okay, and if it's
most of the time going to be one of those.
If you're running it in an emulator, it's normally x86, right?
It's normally probably x86-64.
Okay,
but
gotcha.
Yeah, it's going to be either x86 or x86-64, unless you're on like a Mac M1 or M2 that has an ARM chip, right? And then
that would be cool.
It'll right. So it's going to be, if you're running it on an emulator, it's going to be the same architecture as your CPU, unless you're explicitly emulating a different architecture. Right. You can run an ARM. Yeah, it's just crazy slow.
Yeah. Okay. Gotcha. So you go through the full step and install Frida on your Frida command line on your computer and Frida server on the thing every single time. Your boy is a little bit lazier than Joel.
Yeah.
And
I don't do it every time.
Yeah.
I usually just like have it on the device, and then if it doesn't work, then I'll like update them both.
Okay. So
I have some helper scripts and stuff.
Yeah.
But yeah, like I mentioned, there's two steps. There's Frida server on the device, and then the second part is Frida CLI on your computer. So on your host, you're going to use pip, and you're going to pip install Frida-tools, and that will install the Frida CLI on your computer so that you can interface with the Frida server that's running on the device.
Nice. What I always do, I'll throw this little tip out there, is I always go to my command line and run Frida -- version, and then get the version, and then go to the releases and download that version for the server, and then throw that on the device so that I don't, have any version mismatches because they don't like that. So yeah, but that's probably the better way to do it.
Yeah. So for on the device, there's a couple like main things that you want to be aware of.
Yeah.
So the first is generally you want the device to be rooted. For an emulator, you can easily root them with this tool called Root AVD. We'll link it. It's super great. It will basically root the image itself so that you have SU and all that kind of stuff. You can get root over. You can just SU to get root on ADB, and it makes everything super easy.
Yeah,
straightforward.
Well, okay, so quick question about that, because I normally just run ADB. What is it?
ADB root.
Yeah. Did I have that automatically installed, or what? Or is that only for images?
Are you using GenyMotion?
No, I'm using AVD.
Yeah, so I think that's what gets enabled when you do that. You can I think it lets you do ADB root, or maybe you can just
it only does it on some of the emulators, because like on the ones that have like the Play Store attached to it.
That's what it is.
Okay, so you actually can root the ones with the Play Store?
Yeah. Oh, that's what I mean. Yeah, so use root AVD to root the Play Store images. Yeah, so that's a good distinction. There are two. There's like the like default builds. I think they're like like I forget what they call it, Google API or something. And then there's Play Store version, right? And so the Play Store versions have Google Play Store services. They have the Play Store app. They have all the Google like built-in like Google app services, all that kind of stuff installed already that lets you download apps, and it's basically like default Android. If you use just the Google APIs one, it's like very, very bare bones. It doesn't have Google Play services. It doesn't have the Google Play Store. It doesn't have like any of that kind of stuff. The problem is that a lot of apps rely on Google Play services, so most of the time you need that. It's really hard to install that on just like a stock Google API image. Yeah. They call it a production build, right? So if you were to run a Google Play image, like emulator image, and you were to try to do ADB root, it would say ADB root is not enabled for production builds. And that's because they consider the Google Play build to be a production build. Right? So you have to use root AVD to root that image so that you can have it. You can have SU access while you have like Play Store and everything enabled. Otherwise, yes, you can run ADB root, and then everything you run through ADB will be root by default.
Gotcha. Okay, that is a tidbit that I did not know that I've struggled with in the past, because some of these things really do require the Play Store pieces, and if you don't have root, then you can't run Frida very easily. So then I have to go the other route, which we'll talk about later, hopefully if we have time, which is the patching the APK route. But before we get down that rabbit hole, so, we get root on the Android device, and then we get Frida server on there. How do you just normally how do you get
root? I use ADB push. So like you download the server on your host on your computer, and then you ADB push the file to data/local/temp. That's the go-to directory. It's a unique balance on the Android file system because of the way that permissions work across different folders. It's a place where you can set things as executable and execute them.
Nice.
And download stuff, and you have write permission, and it's a temporary folder. So basically some things will stay in there, but it's used by the system for other temp stuff that gets auto removed. So it's kind of a nice place. If you read all the docs, most of the time they'll tell you to put it there. So push it into data local temp. You're going to need to set it executable. So chmod it. Either I think 755 is what they tell you to do. You could probably plus X.
That's what I do.
But just 755 or plus X, and then make sure you disable SE Linux. SE Linux is enabled by default on Android. It's going to cause problems with like cross-process communication, all that kind of stuff that Frida needs to be able to do. So set enforce space 0. That will turn off SE Linux, and you can type get enforce to check what your SE Linux status is. It'll say either enforcing or permissive. So you want it to be permissive.
Nice. I don't know that I've ever done that. So I think maybe some of the other images have, like, some of the images that are not the Play Store images have it disabled by default or something like that for debug purposes, or I'm not sure.
Yeah, I'm not sure. Like sometimes you run into it more than others, but it'll be pretty obvious when it's an SE Linux error and you need to disable it.
Gotcha. Okay, so then you've got the server running, you've got the client running. Now the connection.
Well, server's not running yet. You need to run the server. So like data/data/local/temp/Frida server. In the newer versions of Frida, there's a -D for daemon mode. that runs it in the background automatically. So it used to be that you'd put an ampersand after it and just do it like that as a background process. Now you can just do /D and it will run it in daemon mode. It has that built in. And now your Frida server is running. Now on your host, if you type Frida-ls-devices, you should see your Frida server like instance basically listed there, showing that it's running, it's connected, it sees the device, you're ready to go.
Frida-ls-devices. Solid. And that just validates like what devices are connected to Frida.
Yep.
Okay. So then you've got your server up, then you can do the fun stuff.
Yep. Now you're ready to run the script. So if you're using the Cert Pinning script, for example, typically what I would run is Frida-U for USB, which basically tells it to use like a plugged-in device, not the host machine. Because you can run Frida like on processes on your host machine. So you want to distinguish, I want to do this on a connected device. So -U for USB, and then -L, and I'll point that to my script path, -L for load script. And then typically -F or -N, depending on whether I'm attaching. So -F is for spawning a new instance of an app. It'll launch it and then attach it at the same time, versus -N is for attaching to an existing running instance of an app. So if, for an example, the app crashes on launch, if Frida's attached, which sometimes happens, then you might need to launch the app, then attach Frida to the running instance, and you'll be good to go.
Solid. Okay, I love how you just pulled all that out of your head. Every single time I do this, I'm like getting into, my command line, and then I'm like typing Frida, and then I just press up, and then inevitably I don't find it, and then I resort to, when you're really desperate, history, pipe, grep, Frida, and then you can see the whole list.
Do you use FZF Fuzzy Find?
I don't actually, and I have.
That's really good.
I have Fish. I use Fish as my primary, CLI, which I love. I love Fish, but also let me say I a little bit regret it because obviously the syntax is different than Bash, right? So if you do something like ZSH, it's intercompatible. But now all of my scripts that I've been writing for the past, couple years are in Fish. And so if I ever try to like switch computers into like, I've seen, we all
surely you can chat GPT that. Come on.
Yeah. Oh, that's a good idea. That's a good use for it. But whenever I'm trying to like jump onto a server and trying to like pull down my config, none of my scripts work by default because they're all Fish, and it's like, what the heck?
Yeah. I really like ZSH, but FZF, it's really good. It's called Fuzzy Find or Fuzzy Finder. And it's basically like a better version of Control R or history search on terminal. And it also works for like finding files on your file system. If you just type FZF, it'll look in your local file system, and it's like basically fuzzy finding, right? So you can type like parts of your command. You could type like Frida, and then you could type maybe an app that you've run before, or like -N or something, and it'll fuzzy search across your commands, like not just exact search like how reverse search is. And it's really, really good.
Solid. I just added that to the notes for the description. That looks super helpful. They've got something a little bit similar to that with Fish by default, but yeah, that seems better. Okay.
Anyways.
Yeah. So Joel knows his command line flags. I do not know my command line flags. That's the TLDR of that.
I've run
situation.
a Frida script or two in my day.
Yeah, I can see it. Okay, so we've got the server running. So when you say -F or -N, you're launching a process. So normally what that looks like is you are giving it the package name, right? For
launch,
APK.
you give it the package name, and for attach, you give it the app name. That's also a new thing. It used to be that it was the package name for both. If you do Frida-PS space -U, again, -U for like USB or connected device, then that will list the processes that Frida sees, and it'll show you, like if you have a running app, it'll show you the app name, right? It won't show you the package, and then for the rest of them, it should show like the package. So that's kind of how you'll know. But if you want to, that's like one thing that you do need to either look up or be aware of, is if you want to spawn an app and you only know the name of the app, you're going to have to find the package name. Yeah. That's not hard to do, but just be aware.
Yeah, no, that's gotten me recently because I was like, why is this Frida command not working? I copied and pasted from the last time I used Frida, and then it was like, Yeah. Okay. So there's some differentiation there. I love how you are like a walking Frida documentation. I dig that. So we've got it running. We've run the script. Decrypts the SSL cert pinning. Happy day. Now we're able to use the app.
Right.
We can talk about custom SSL cert pinning implementations, but the other thing that I want to jump backwards a little bit. So in this situation, this assumes that we are using a rooted device, because you can't just have other processes hooking into other processes if they're not root, right? So what about the situations, Joel, when you cannot use a rooted device for whatever reason, like the app flips out if you're on a rooted device? What is your approach to that?
Yeah, so it depends on how they're doing their checks. Okay. Typically, we did mention like you can patch the APK, so that is an option. There are ways to get Frida within an APK through patching. Essentially, you put the a Frida native library into the app, you re-sign the app, or you edit the Smalley code to load that library, which will be the same as launching Frida server, but within just that process, right? So instead of being system-wide Frida, it's I patched this APK to load Frida specifically, and it has Frida, but nothing else does. And then you can attach to it like you would with Frida server, but it's just that single instance of the app. You can do that, or you can just edit the Smalley code, and you can, make changes, recompile it, re-sign it, install it, run it. And that could be your workflow. It's just a lot slower. It's a lot more tedious. There are definitely cases, I think most often I would say like banking apps, money apps, those have the most stringent type of security policies that you have to have for device security. So it like is the device a secure environment, essentially, like mainly for like protecting people's money and identity theft and all that kind of stuff. Just the types of stuff that you can do through mobile banking apps and mobile money apps nowadays are equivalent to walking into the bank. So they have to be very, very secure about that type of stuff. They want to make sure your phone's not compromised, all that jazz, right? Yeah. So those are probably where you're going to run into a lot of these issues, and they're going to be like complex type of systems that are going to try and stop you from running on a rooted device. They might be using stuff like attestations that are going to be verified on the server side before you even log in. That is probably going to be the trickiest situation because attestation stuff is implemented at like an OS system level by Google, either through the Play Integrity API or the Safety Net APIs. Both of those are like really hard to get around and bypass and spoof, just because of where they're located. They're like lower than Frida. So, and they're like very complex native library driven systems that are hard to intercept. So it's just like, it's not an easy task to overcome. However, generally speaking, you'll probably be able to get around most things with either just straight up Frida scripts or manually patching the app. Yeah,
that's a good point. So just if for example, you run into a situation where you don't, if you run into a situation,
drops them.
If you run into a situation where you are, the app is like, hey, you're rooted, don't do that, I don't know why my app's a cat.
Your cat is a mad cat.
Yeah, exactly. But, then the first approach I'd imagine is let's just disable that. So, you go into the code in VS Code if you're cool, JADX, GUI if you're not, and then you find the place where that root function, that root check is being done. A lot of times I do that via taking the error code and then just kind of working backwards, figuring out what string.xml that is, and then figuring out where that string.xml is located in the actual Java code, and then narrowing down what function is doing this this check. And then there's normally a function that just returns a Boolean that's like, is rooted true, is rooted false, and then you can just overwrite that with Frida and change that false to a true, or change it to always return false if it is rooted, that sort of thing.
Right.
And for those of you that are a little bit intimidated by that task, if you look at Joel's SSL unpinner script, you'll see these functions, these actually assignments, variable assignments. I'm looking at the one on line 34 here. certificatepinner.check.overload.implementation. What he's doing there is he's selected the specific certificate pinner class on line 33, OKHTTP3.certificatepinner, and then he's selected the check function and selected the overload for that, because there's multiple check functions depending on the parameters, that takes a string and list. And then he's taking that implementation and overwriting it with this function that he's defined right after there, which is essentially just saying we intercepted HTTP3 or OKHTTP3, and then we're just returning saying everything's good, right? So that's how easy it is to overwrite functions, just arbitrary functions inside the code.
Right. Yeah, so the way that this check works, typically it would throw an exception. Yeah. So that's why you're just doing a return. Right. Typically, the way that it would check is it's a void return. It doesn't actually return anything. It just executes. And if there's a certificate error, it throws an exception, which would get caught by whatever's calling it. So instead, you just exit out immediately. There's no error, no problem. Keep going.
No error, no problem. No error, no problem.
No error, no problem.
Okay. we're in a goofy mood today, man. Okay. So going back to the using Frida on an Android without root. There's a article that I wanted to call out that's like my go-to article for this, that I just I remember very vividly when I started learning about this. This article by a person called IKOZ, IKOZ.
Yep. I love that guy.
Yeah. And so let me pull up his Twitter as well. I don't know if it's just IKOZ. Yeah, it's just IKOZ. And he does an article called "Using Frida on Android Without Root." Very, very, very apt name. And he walks through, the basics of how to do it, and in detail, doing exactly what you would need to do. So that one's great if you really want to understand what's going on. When I was first learning, I went ahead and manually patched the Smalley code, which is kind of a tricky process, but it was good to understand what was happening. And then ever since, I have been using this tool called Objection, which I'll also link in the description, an article by NetSpy, NETSPI. And let me just pull that up right here. It's written by Cody Was, and it's 4 ways to bypass Android SSL verification and certificate pinning is the title. And just really good information there on how to use Objection and some other ways to get around certificate pinning. So I'll link both of those. Excellent resources. Like Joel said, you probably shouldn't have to do this too much. But if you do, it's good to be able to do it, and it allows you to get around some really tricky situations. So
yeah, Objection is pretty good. It's like I refer to it as kind of a multi-tool. So like multi-tools, if you've ever had a multi-tool, like it's like the knife version of a multi-tool, it's like, it's pretty good at a lot of things, but it's not going to be the best knife. It's not going to be the best pliers. It's not going to be the best screwdriver, right? So that's where you're going to want to dive into individual tools that really specialize in the specific areas. But as a general all-around tool that can do like a lot of different things, it's really good for that.
Yeah, solid. That makes sense. So check out Objection if you're in that sort of situation. Okay, so let me look at the doc real quick, because we're getting long here on time. Okay, so we have a root detection. Let me give you a hypothetical. We've got a root detection function in there. Did the flow that I described, tracing it back through the strings and that sort of thing, did that resound with you? Is there any other tips and tricks you have for finding where the functions are in the code that do the thing that you're trying to make not happen?
Yeah. So, I mean, what you described is generally the first place I would look. Okay. See, is there an error being on the screen that I can search within the app, find a string, find where it's referenced in the code, trace that back, see where it's thrown, see what's causing this pinning, etc. Right? Yeah. Trace it back from a known thing. That is probably the first thing that I would try. If I can't get anywhere with that, I would probably check logcat. Which that's you can do with ADB logcat. There are a couple different flags you can throw on logcat that will let you filter by a specific app or a specific PID. So you'll only see logs for just that running app, which makes it a lot cleaner and a lot easier to read and understand what's going on. I'll check logcat because logcat might have an exception thrown. It might have an error message that's related. Like similarly, that it might not be shown like on the screen, but it might be in the logcat that's showing either a traceback or an exception or some kind of log message that I can also search for in the code. And then if that doesn't work, I'll start searching for generic terms. I'll start searching for pin, pinning, certificate, maybe even like SSL or verification or something like that. And I'll just look and see. If I still am not finding anything, then I'm just going to like start digging through package files that are related to the app. Like, you know, it's like you just got to keep going. It's going to get grindy after a certain point. Yeah,
I imagine so. And yeah, I mean, most of the time that should get you there. The only other time that I've kind of run into a situation where I was like, I cannot find this function, is, you know, sometimes these functions can be in native libraries, right?
Yes.
So talk to me a little bit about this concept of native libraries and how it makes our life more difficult as an Android tester.
Sure. Yeah. So native libraries are basically portions of the Android code base that are written in native C or C++. So it's like, say you have this hash signing or like for a legitimate use case, it would be something that you want to run faster than it can in Java.
Sure.
Right. Or take advantage of like native C++ level bindings or certain C++ libraries or something like that. You would write it into C++. And then when you build your app, you would get out a .so file, right? Similar to what you have on Linux. It's just like a dynamic, like linkable library. And it gets loaded from the Java side using system.load library. And typically the bindings within that library. So there'll be a method called JNI on load. There's a whole set of methods. They're called JNI methods, Java Native Interface. And basically they define like how JNI libraries work. So when you call like system.load library, it will automatically call JNI on load when it loads the JNI, right?
Okay.
And so from there, a lot of things will happen. It'll do some mapping from function names within the C++ to function names within the Java. So you'll see in the Java code, for example, if in the Java code base, you'll see what looks like, this is getting a little technical, you'll see what looks like an abstract class definition.
Oh, really?
Where it will have functions that are listed, but they have no bodies. And they'll be defined as native within like, you know, native void, whatever, or like native string, right?
Is that a decorator in Java? What is that?
No. It's like one of the like precursor keywords that says like, you know, where like you put like void or like
really?
public or static, right? It's native, right? And so you're saying like this is a native function. And in your C++, say you had com.example.myClass.
Sure.
And then you had a function called like do something.
Right.
Okay. In C++, your function would be Java _ com _ example _ myClass _ do something.
And that's how it knows to associate the abstract class to the implementation, which is in C++.
Correct. And it has to have like a similar function signature and everything. It'll throw errors if it doesn't.
Sure.
Alternatively, and this is where things also get trickier, is if they don't do that, they can do it through JNI on load. There's this thing called registered natives. And this flew under the radar for me for a while until I figured out what it was. And basically, it lets you register a native method to a specific signature. Like in the same way that you would name it by that string, you could say, oh, this string should actually be associated with this pointer.
Yeah, I'm seeing that.
And call this pointer instead, right? And so that means that they can obfuscate the native library to like Kingdom Come. They can do whatever they want with it. They can hide those strings super, super hard. Like the signature string, for example, they could have like custom string encoding and decryption that results in that string. And then all they have to do, there's, you know, one assembly instruction in there that's calling out and registering the natives and pointing it to that pointer. And you're going to have to figure out which pointer it is or which function's actually doing this stuff.
Yeah.
There are a couple things that can help with this. I'm blanking on like what they are specifically, but there are plugins for Ghidra and for IDA that both will help map the JNI calls. So they have basically loaded up the JNI header that has the offsets for like all the structs, and then it will rename the references and say, oh, it's calling on load here, or it's calling register natives, or it's calling get class. Because there's like, this is also how you would, for instance, like if you want to use a Java string class, you have to do it through JNI native bindings. So you would do like get class, and then you would get an instance of like a C++ pointer that points to that class, and it's
Dang,
Java
dude,
through C++.
That is a very convoluted process there. Okay, so I'm gonna try to simplify it. So normally the normal situation is we've got this class, this abstract class, and the function names are appropriately named in the native library, and then it just kind of shoves those implementations into the abstract class, just like you would do, in normal, object-oriented programming. But
then and that's the simplest case.
Yeah, and that's pretty much the only case that I've run into that I could find. Yeah. But also, I was going to talk about this other case that I couldn't figure. So maybe actually that was what was happening. I should have called you in this scenario, because I had this one time I was like, man, I cannot patch this. And I actually ended up, all I needed to do was change one letter in a header so that I could overwrite it instead of, and I actually ended up literally patching the native library. I literally just opened it up in a hex header and like searched for the string and like replaced one of the characters in the string, and it changed it, and it worked beautifully. But shout out to Space Raccoon for that awesome idea. But then maybe it could have been the register natives thing that was getting me there. So that's hella complex. I don't even know what I want to ask here.
It's super dense. This is the thing with native libraries is like generally native libraries are like, it requires a whole separate skill set, right? Because you have to be familiar with assembly code. You have to be familiar with like pointers and like C++ and like JNI, which is like a whole other thing. And so it does definitely take like a lot of like extra like effort and resources. I wouldn't really recommend unless you need it to like dive into all of that, unless it's something that's really interesting to you. But it's one of those things that I've kind of only like learned out of necessity. Yeah. And it's like a very like complex, and it's super hard to like reverse engineer and like come at it the other way from.
Solid. So I'm looking at this thing here. The only other thing that I wanted to pick your brain on, just on my hit list here, was like, okay, let's say that I've had this scenario happen a couple of times where I was like, okay, I found the function I need to overwrite, and like for some reason it's not letting me overwrite it in Frida. There's this thing. I think I messaged you, and I think we came up with the conclusion. Let me see if I can find this app or this script. Yeah, here it is. So what we ended up doing was java.perform, and then we put the function call inside of it. And then what I ended up doing was having to run setInterval, which is a JavaScript function which runs a function at a set interval, very aptly named. And then it would run that function again, and then whenever that function got defined, it would just overwrite it. Why is that happening, and why do I have to use this setInterval function to overwrite the specific function? This is a very specific question.
Yeah.
Sorry about that.
So we were talking about this, and it was in a native library, right?
Yeah.
The function. Yeah. So the reason is, as I mentioned, native libraries don't get initialized until you load them. So you have to call system.loadLibrary in order to initialize the native library within the Java context. If you don't do that and you try and call it, it's going to be like, I don't know what you want me to call. Like it doesn't know. It has to be loaded up into memory. So you essentially had to wait for system.loadLibrary to be called by the app before you could hook that function. And that's why you had to keep doing it on a timer until it got loaded up. Once it got loaded up, then you can hook it.
Solid. Okay. So the native library had to be loaded up, and that wasn't happening till a later point after the Frida script was running. So when the Frida script, there's like a little race condition there, right? When the Frida would run, then it would be like, what the heck, this function doesn't exist. And then afterwards it would get defined. So when I went ahead and stuck it in the set interval and put like a try catch statement in there, then it would say like, okay, nope, not there. Nope, not there. Yeah, yep, they loaded it. Now I'm going to override it. Is that accurate?
Exactly.
Solid.
Yep.
Okay, cool. Well, actually that leads quite well into my report. You down to jump into that now? You got anything else you want to say on dynamic?
I did have two things that I wanted to mention. Yeah. Actually, one thing, because I think one of them we mentioned. I think we already talked about proxying over USB with ADB reverse.
Yeah, in a different episode. Yeah, I've been using that all the time.
That's not really dynamic.
Yeah, that's been helpful.
Yeah, Yeah, not really a dynamic hacking thing, but certainly quite useful, especially since we talked about hacking on physical devices. Another thing with physical devices, and this is the other thing, there's a tool that was made by GenyMotion, or GenyMobile, I guess is the company. It's called SCRCopy, SCRCPY. And it's basically just a tool that lets you display your Android, like a physical device screen. You just plug it in over USB, and you can view and control the screen on your computer. So you don't have to like pick up your phone and stuff. It also does like clipboard transferring, which is super nice. You can just like click and drag stuff. It has the buttons. It's great. It's like in between Android emulator, but physical device. Makes it a lot easier for doing a lot of testing.
For those of you listening on the podcast, I'm just sitting here with my jaw dropped right now. This is super cool. So is this
super awesome?
Like it just mirrors the screen onto your computer and lets you. Dude, that's so helpful. Oh my gosh. And is it hard to set up? I mean, can I just use this with Air, like the Android Studio? I don't have to use like GenyMobile's thing, do I?
No. It's a fully separate package. They even have here, you can get it with apt.
Frick, I love this. No way, really. What it oh my gosh.
Apt installs SCRCopy. Yeah. Screen copy, I guess is what it's short for. But yeah, on Mac you can use Brew. They have install docs in the README on their repo. But yeah, it's a super useful tool. I use that like 9 times out of 10 when I'm using a physical device, just because it's a pain to have to like pick it up and have it connected somewhere that I can touch the screen and all that kind of stuff, and all the copy pasting and all that, whatever.
Dude, that is a game changer right there. I'm installing that right now. Oh my gosh, that's going to be real cool. Okay, I'm putting that in the show notes. Let me get that. Any of you guys who do mobile hacking on a normal basis, that is. Oh, you got it. Nice, you beat me to it. That is a game changer right there. Dang it, Joel! Why didn't you tell me about that before, man? This is.
I was thinking about it, but we had already moved on when we were talking about the physical versus emulator thing.
Yeah.
And then we moved on to JADX, and I was like, I'll just write this down, and it was like on my sticky note until the end.
Well, I'm glad I checked in with you again rather than just jumping right into the reports, because that would have missed out on that juicy tidbit. Yeah. So all right. So ADB reverse, that's in episode 6, and then this SCRCopy.
Yes. Screen copy.
Nice.
To display your physical device on your host.
More bangers from Joel, guys. Frick, I love that. Okay. All right. So let me jump into the report for the day. I was looking on HackerOne Hacktivity stuff, trying to find a disclosed report that we could kind of talk through with Frida, but there's pretty much nothing, which was really surprising to me.
Yeah, it's really interesting. I think part of it is that Frida scripts are kind of like special secret sauce a lot of the time. A lot of people, either they have their own script suites, or maybe over time they have like figured something out and they don't want to just put it in like code basically that anybody could download and know like, oh, this is how you do that. So I've tried to push away from a lot of that, like by publishing my Cert Pinning script and that kind of stuff. That's kind of like a big long-standing problem in my opinion with most of like the mobile hacking space, is that a lot of it is like secret knowledge that people have like built up over time, and they don't really talk about it. They just like show the cool results, which is really cool, but it doesn't really help build like a strong mobile security community that can like expand and other people can learn all that kind of stuff. So I try to be as public as I can about a lot of this stuff. Yeah,
dude, I definitely appreciate that. So thanks for sharing the sauce there. Let me just talk through this report really quickly. So this one was a little bit of an interesting one. This is a high, and this was an ATO on a specific service that I can't name, but there was this service where several people would come together and they would help provide care for another individual. And the way that this service sort of worked is, it was primarily done through an app. And that app was using SSL pinning, but it wasn't just using any SSL pinning. It was using custom SSL pinning, which is actually, we didn't get super much into that. So I'm glad we have this report so we can talk through it. So it was using, I fired up Frida through Joel's universal, unpin at it. And it wasn't allowing me to see the traffic still. I was still seeing, in one of the ways you can tell that you're not seeing the traffic is if you go to Burp and you go to let me just pop Burp open right now. Yeah, if you go to dashboard and then you go to event log, down there it'll say client failed to negotiate a TLS connection. And that will tell you that, cert pinning is sort of in place. And you also see some stuff in the app as well. And so the situation here was that they had a custom cert pinning implementation, and there was a function that I'm trying to say it without actually giving away too much of the details. Anyway, there's a function called TLS config, and it was there's a class called TLS config, and inside of that was a function called set verify server. And this was, so this is a classic, and it returned a Boolean, right? So this is perfect for just kind of what we were talking about. It's a simple fix. You just find that class and find that function, and then you just overwrite that function with your own implementation that returns false. Now, here is some big brain tips, okay? And this is one of the reasons, I forgot about this before. This is one of the reasons why I do use JADX GUI as my GUI of choice for auditing Android apps. Inside of JADX GUI, you can right click on a function and hit copy as Frida snippet. And this will literally take the function class, take everything, just give you this beautiful Frida snippet, and then you can just drop it right into a script and run it, and it will overwrite that function and give you like logs with that function when that function gets called. Sorry.
That is pretty neat.
That's pretty freaking cool, right? So I did that and put that in there, and I was seeing that it was getting called, and then I just went ahead and overrode it with set to false. So that allowed me to see the traffic for the specific service, which was under audited because of this custom SSL pinning. And when I went into that traffic, I saw one of the functions. There was an impersonate function where these group of people can help this other person do their job by impersonating and like taking over their screen or whatever and doing the action for them. Whenever you see stuff like that, you should be hearing the cha-ching from the bounties because that is normally very, very hard to implement properly. And I was hoping that I could potentially just put in, any user's ID, and it would just let me, impersonate that user. Wasn't the case, but it did allow me to put in the ID of somebody on my care team, and then get the access token for them. So the other people that are kind of working in the same scenario as me to help, this person do their job, this other person do their job, I could take over their accounts. So then we got arbitrary account takeover in that way on those accounts, and that resulted in a high vulnerability. And I would never have found it if I hadn't gone through those loops to get rid of that SSL cert pinning. And I have to say, sometimes it can feel really like I just spent 5 hours, trying to bypass SSL pinning and stuff like that. But just like we talk about all the time with getting access to scope or paying the extra $50 to get the premium feature, or getting access to scope that other attackers aren't willing to go through the effort to get access to or aren't willing to pay the money to get access to, that almost always produces amazing results. So taking it a little bit further, bypassing that custom SSL pinning implementation, bypassing that root detection, can often land you some pretty sick bounties, even in the HTTP realm. It doesn't necessarily have to be some crazy mobile bug, but it can also just be an HTTP, REST API bug as well.
Yeah, 100%. A lot of that security through obscurity stuff happens in the mobile space just because people don't look at mobile and people don't understand mobile and people don't know how to get past some of the basic security measures that exist on mobile, like cert pinning. And as a result, they just put a lot of really crazy stuff behind that.
Yeah. Absolutely. So that's cool. That's the report I had. You got one you want to talk about, Joel?
Yeah. So this is actually my first ever bug. This is the first ever report I created on HackerOne.
No way.
It was This was at the H1702 2017, my first live hacking event, my first bug bounty anything, and one of the targets was Uber, and they were they had put up a challenge. They had a specific couple of challenges, and one of the challenges was to bypass the jailbreak detection on their driver app. And nice. I was like, oh, I can definitely do that. I use Frida all the time.
Yeah.
I could just hook a couple of methods. And so I spent all night, I hadn't done any hacking ahead of time or anything, because I was super out of the loop on all this stuff. So I just like sat down and I just like dug into it, and I wrote up this like crazy long Frida script that hooked a bunch of different things, and yeah, I bypassed it, and I actually got to do a show and tell for that.
No way,
like
really?
Again, it was my first live hacking event. I was like, I had no idea what was even going on. I was like,
yeah,
so out of it. I was so like, what is all this? Who is this Franz Rosen guy?
Dude, well, congrats, because that's, I mean, getting to do a show and tell at your first live hacking event is nuts. That's how you can tell you got some serious, you know, you're in the right place. But yeah, I will say I have seen a couple challenges like that where people will put like, you know, if they have a mobile app and scope, they're like, hey, if you can bypass our root detection, we'll give you, you know, a medium or something like that. And I always eat those up, man. Like I have, I'll just pull up my.
I've got more than this one. I've
got
plenty of
3 or
highs
4
that I've gotten from bypassing that type
really?
of stuff.
Wow.
Because yeah, most of the time the problem is that the checks are on the client side, right? So like they're very trusting towards what the client is sending, and they just assume that the stuff that if the client has gotten that data, that it's legitimate. And you can either just feed in fake data to the client, or you can bypass those checks and make it look legitimate. And then the server will trust a lot of that stuff, and you've already proven impact.
Wow, that's crazy. Yeah, so I've got a couple of those. I have never been paid more than a medium for it. But apparently there's highs out there to be gained. And like Joel said, there's pretty much, you know, it's almost always possible, right? You know, because there's all of this code that's running on the device is in your control if you're running on a rooted device. So you should be able to theoretically go in there, hook the right functions, return the right values, and bypass the whole thing. So definitely something to be on the lookout for there.
Yeah. Cool. I think that was it for me.
Yeah,
this was a long episode. I know there was a lot of data condensed in here. But yeah, I hope that it was helpful.
Yeah, for sure, man. It always is. And yeah, I'm looking through here. I think we hit most everything, so that's good. We still have so much more to cover in mobile, so there'll definitely be more mobile episodes to come, and it seems like you guys really enjoyed the last one. So yeah, we'll definitely keep those coming at a pace where you can take some time, digest all the wisdom that Joel has imparted to us, and yeah, become better mobile hackers. So is that the pod?
Cool. I think that's the pod.
All right, peace.
Peace.